This is a video about the center of mass, also called the center of gravity. These 2 points, which are defined here, center of mass, the point around which all the mass or weight is evenly distributed, basically the balance point of an object. As long as the strength of the gravitational field is the same in the whole region that you're interested in, the center of gravity and the center of mass are the same point. A case where this would not be the case would be if you had a really tall skyscraper, and as gravity strength diminishes as you go higher and higher above the surface of the earth, then the center of gravity may be a little bit lower than the center of mass because of that reduced gravitational field strength. But that's not the case if we're just looking at bodies and small objects. Now, if you look at those 2 cute little videos that I linked, you'll realize that the center of mass of a body doesn't have to be inside the body, and you can change it by just moving your arms and legs around. So if you're just standing with your hands off to the side like this, and your center of gravity is here, well, by shifting one arm down and one arm out, you can move your center of gravity away from your body. Something you have to realize, if you're doing a vertical jump test, your center of gravity can only go so high based on how hard you can push off the ground with your legs. But the height at which you can reach is different depending on what you do with your body after you leave the ground. So if your center of gravity can only go this high, so your legs are only so strong, and that's how high the center of gravity is going to be off the ground. Well, if you keep your legs straight, and well, I guess this might be higher here, and lift only one arm, you're going to be able to reach a higher location than if, for example, you lift both arms, because lifting both arms moves your, whoops, your head's up here, moves your center of gravity up in your body. And so you're not going to be able to reach as high there. And you're not going to be able to reach as high as if you use both hands. And if you were to kick your feet up in the air, then that's not a very good idea either, because then you're not going to be able to reach as high. So if you want to be able to reach as high as possible, you want to do it one arm only and keep your legs straight. Now, your stability and whether or not you're going to tip over depends on where your center of gravity is with respect to your base of support. And so what the base of support means is, base of support is the area that is, okay, if those are your 2 feet, your base of support is this area here. And so you can see that if you put your feet further apart, say these are your footprints on the ground, so you're much more stable if you put your feet further apart. If you use a cane, or if like those football players who crouch down and they put one hand out, that's 3-point support, then your base of support goes way up. That's why you're much more stable if you use a cane. So there's a cane over here. Now your base of support, oh, what happened to that? Your base of support is this whole region here. So as long as your center of mass, as you manipulate your body, is vertically above this base of support, so these are the areas on the ground, you can actually draw these areas on the ground, then you won't tip over. But as soon as that center of mass moves away, you're going to fall over. So for example, if you try to lean over, like say this is your body here, if this is your center of gravity, and that's where you put your gravity vector, that's where the force of gravity tends to act, at the center of mass. It's called CM for center of mass. You're going to tip over because your base of support's back here, and that gravity vector has to pierce through that base of support on the floor, otherwise you tip over. So this is clearly going to tip over. Now, there are stable positions and unstable positions for objects. If you have a box, well, this is pretty stable. That's your center of mass and that's your force of gravity. This is a very stable position for the box to be in, but you can take that same box. You can have the center of mass over the base of support. Put it like that. This will balance, but certainly unstable. Because if you disturb it just a little bit, obviously it's going to fall over. So even if you have your force of gravity over your base of support, you can still be unstable. And this is why the taller something is, the less stable it is. So if you have a really tall box with a high center of gravity, so there's your force vector, you don't have to tip it far to get that force gravity to be past this point here. So if we're way up high here, this is going to tip over. And he didn't tip it very much. Whereas if you have an object with a low center of gravity, like this box, you have to tip it quite a bit to get it to tip over. Like way over this angle that you've had to tip it to get it to here is much bigger. So that's why you want to, if you don't want someone to knock you over, you crouch down, and that's a much more stable position. So you lower your center of gravity by bending your legs, and you become, so this would be, this is your bent legs, low center of mass is more stable than here. This is with straight legs and standing bolt upright. So that's why you take that low bent-legged stance if you don't want someone to push you over. So this is unstable. Okay, so our bodies are pretty good at adapting, and we know how to shift our weight to keep our weight over our feet. And that's why that example in that little video of the girl standing, you should try it. Stand up against a wall and try to pick up something, try to bend over and pick something up in front of you. But you can't do it because your center of mass is immediately going to come out here into outer space when you bend over, and then you're going to tip over. What you need to do to be able to pick that thing up, and if you notice, if you do it without the wall, is your butt will come way back. And even though your center of mass, and then you can reach down and pick something up, your center of mass is still out here, but now it's over your feet. So you'll be able to pick something up as long as you keep that gravity vector over your feet. Okay, so how are we going to calculate center of mass? That's what we need to be able to do. So there is a fancy formula for calculating it. And it looks like a scary formula, but it's not so bad. And we'll do a bunch of examples. Now, I'm just constantly switching between center of gravity and center of mass. It just doesn't matter. They're the same thing. We'll call this center of gravity. Okay, so the fancy formula looks like this. It's a sigma, a little I on it. And it's MIXI divided by sigma. So that's a Greek letter, capital sigma, MI. What that means is this sigma symbol means you add. So you go 1 plus 2 plus 3 plus 4 plus 5. And you put in I. So this would be M1x1 plus M2x2 plus M3x3 and so on, however many individual masses you have in your system. And then on the bottom, this is just the sum of all the masses. On and on. Okay, so that's the X direction, and then similarly in the Y direction, it's the same formula, but you put the Y. So it's MIYI over the sum of MI. Okay, so how do we do that? Let's just do some examples. And then, so the X center of gravity, Y center of gravity, that is a point in the XY plane. And that's the point you're after, the center of gravity or center of mass of the object. Okay, so let's just do one we have objects on the x-axis. So say we have two masses. two balls, 2 kilogram ball there, and a 3 kilogram ball over here. Now, if you imagine that you were to put on a barbell a 2 kilogram and a 3 kilogram, you wouldn't be able to balance the barbell in the center. It would tip over to the right. So the question is, where could you balance this? It's going to be closer to the 3. So it's like we're looking for this point here where I could put a little fulcrum and balance that barbell. Now we're not going to worry about the mass of the line joining the 2 points. We just want to know what is the center of mass on this x-axis. So this is the x-axis for these 2 masses. Now we need to know how far apart these 2 masses are. So we'll call this the origin. So this is O, and then we'll call this, say the distance is 4 meters between them. Okay, so our 2 masses, M1 is 2 kilograms. X1 is 0 because it's at the origin. M2 will be the 3 kilograms, and X2 would be 4 meters. So that's the location. Okay, so X, center of gravity, according to the formula, is M1x1 plus M2x2 divided by M1 plus M2. So M1 times x1 plus m2 times x2 divided by m1 plus m2. Okay, so that's equal to 12 kilogram times meters divided by 5 kilograms. Notice how the kilograms cancel. So the position of the center of mass or gravity of those 2 balls equals 2.4 meters. And so that's where this would be a little bit to the right of center between these. I'd put that there, and this would be the balance point. And so that is the center of mass or center of gravity of those 2 masses. Okay, let's do one now where we have x's and y's. Notice how there's nothing actually there. That's just in outer space, that point. That's okay. Okay, so let's now determine the, I'll call it center of mass this time, doesn't matter, center of mass of the following systems. Okay, so now we're going to have x and y. So we're going to put one mass at the origin. It's always handy to put one mass at the origin because then it doesn't have an x or a y coordinate. It doesn't change the position of the center of mass. Doesn't matter where you put your xy axes, center of mass is the same. Just makes the calculation easier. And then we'll put another one here. We'll call this one M3, and we'll let it be 1 kilogram. And then we'll put one up here on the y-axis, M1, and it'll be 4 kilograms. Okay, and this distance will be 3 meters. And this distance here will be 4 meters. Okay, so it's always a good idea to make a list of your M's and X's and Y's. So let's go like this. Let's go the mass, the X, and the Y. So M1, 4 kilograms, X1, 0, it's on that x-axis, and then but Y1, it's up there on the y-axis, is 3. Okay, M2 is 5, X2 is 0, it's on the origin, that's nice. Y2 is 0 as well, so that's nice. M3, which is 1, X, now this has an X, X3 is 4 meters, but Y3 is 0. Okay, so we have a nice table. Now we can go ahead and do the calculation. X, let's call it center of mass this time. M1 x1 plus M2 x2 plus M3 x3 divided by M1 plus M2 plus M3. It doesn't matter whether the M's have X is 0 or not. You have to include them on the bottom. You always include them all on the bottom. So 4 kilograms times 0 plus 5 kilograms times 0 plus 1 kilogram times 4. And then you add them all up. 4 plus 5 is 9 plus 1 is 10 kilograms is the bottom. Okay, so the position of X is equal to 4 over 10, 0.4 meters. Okay, that's the X position. Now I do the Y. The position of the Y center of mass, M1Y1 plus M2Y2, M3Y3 over the sum. Okay, so 4 kilograms. That was M1, what was Y1? 3, and the other two are 0. Okay, so it's 3, and then it was 5 times 0 plus 1 times 0, and you still had to divide by 10. Okay, so this 12 over 10 is 1.2 meters. So the position, X center of mass, Y center of mass, would be equal to 0.4 and 1.2 meters. Okay, so if you went back up here, it's about like 0.4, it's of course kind of maybe right around here. Yes, right around here. Center of mass. Now, if these three masses were like glued onto a very thin metal sheet that didn't really have much mass at all or was just uniform, you could actually put a pen right here and balance those three masses. Okay, now what are we going to do about the body? How does the body work? Well, what you do when you have the body, or let's do something where it's not little point masses. So for example, what if we had something like this? What if we had a block here and then another block like this? Now, where's the center of mass of those things? And let's say this is at 10 meters and 12, doesn't matter what's meters, centimeters, whatever. There's our origin. This will be at 6, and this will be at 8. Okay, so these are two blocks, rectangular blocks. We want to know where their center of mass is. Well, what you do is you reduce them to balls, just like the previous questions. So this is equivalent to, oh yeah, we have to know the masses of these. So this is a 20 kilogram block, and this is a 10 kilogram block. So the equivalent is you take this 20 kilogram block, and it's symmetric. So you know the center of mass is in the middle of it. So where do we put that? Well, the middle is some halfway between 10 and 11. So it's a ball, a 20 kilogram ball, call this M1, and its location here vertically is at 11. And over from the x-axis, it's halfway. So the end of it here is at 8. Half of that's 4. So this would be at 4. So M1 has X. So this is X1 is 4 and Y1 is 11. So we've reduced this rectangular block over here to a ball at its center of mass. Now, what about this 10 kilogram one over here? Where's it? Well, it's at 7. So X2 is at 7. That's halfway between 6 and 8. And then 10, it would be at 5. So it would be like right around here. And this Y2 would be 5 because it's halfway up from 0 to 10. So it's halfway at 5. So this would be M2 would be 10 kilograms. Now we just do what we did in the last question. We've got 2 points and we need to find where their center of mass is. So we use the formula. The X center of mass would be X1, M1, X2. Doesn't matter what order you do those in, M1 or X1 first, but you still have to add both of them together. Okay, so X1 is 4. M1 is 20 kilograms. X2 is 7. 2 is 10 kilograms. And together they're 30 kilograms. So 80 plus 70 is 150 right there. So this must be 5. And I didn't put any units. So whatever like if these were meters, for example, then this would be meters. Okay, so that's the position of the X center of mass of those two rectangular blocks. And then the Y would be Y1. What was Y1? 11, and Y2 was 5. 11 and 5. And you still have to divide by 30. And so its position would be 9. And if it was meters, it would be meters. Okay, so that's how you deal with objects that aren't just point masses. So now you can see how it works with your body. Let's just do a quick example. Where would the center of mass of your body be? So let's say you represent your body with your head, and then your trunk would be it would be a cylinder, but a cylinder has its center of mass at its center as well. And then your 2 legs. We won't worry about your arms for now. Okay, so you can basically be reduced to 4 segments, each of which has a mass. So we'll call this one M1, will be 5 kilograms for your head. M2, your trunk will be 40 kilograms. And your legs together will be 20 kilograms. Okay, now obviously it's symmetric side to side. The X, we could just call this the X axis. And then there's will be the Y axis. Whoops. X. So we know it's at X equals 0 through the center. The question is, how high is it from the ground up? So now we have to know, well, how long are your legs? So your legs are, we'll say they're 80 centimeters. Your trunk, 60 centimeters. There are all kinds of tables that give you these anthropometric values for average humans. Okay, so the question is, what is the height of center of mass? Okay, so all the X's would just give us X equals 0, that's fine. Now let's do the Y's. Now we have to find, we always have to go from the origin. We can't use 60, 80, and 30. We have to go from here, like how high. We need to know this distance, that will be Y3. And then we have to know this distance up to here, that'll be Y2. And then we have to know the distance all the way up to your head, Y1. So all the Y values have to start down on the X axis. They're not equal to 80, 60, 30. So let's figure out what these Y values are. Y3 would be halfway up your leg, so that'd be 40. Y2 is your legs, 80, plus half of 30. So this would be 80 plus half of 60, which is 30. So 80 plus 30, this would be 110. That's how high the center of your trunk is. And then Y3 would be from the ground. It would be so your legs plus your trunk plus halfway up to your head. So 140, 155. Okay, so now we do the formula for Y, center of mass. Okay, so, whoops, I put Y3, that's Y1. So Y1, 155 times mass of your head, which is 5 kilograms, plus Y2, 110 times the mass of your trunk, 40 kilograms, plus 40 mass of your legs, 20 kilograms, over your total mass, which would be 40 plus 20 plus 5, 65 kilograms. And so this would be 92 centimeters up. And if your total height, so percentage of your height, 92 divided by the total height, which was 170. So this is 54%, which they say that's about average. It's about, say, 52 to 58% of your height is where your center of mass is. Okay, that's enough for today.